Imagine a computer so powerful that something taking 13,000 years to solve, it figures out in hours. Not years. Not months. Hours. But here's the twist. This computer doesn't exist yet. Or does it? Welcome back. Today, we're breaking down a quantum computing breakthrough that's got the entire scientific community asking, what just happened? For decades, scientists have been stuck on a problem. There are certain calculations in physics, really complex ones, that even the fastest supercomputers on Earth struggle with. Think about trying to understand how particles behave inside a molecule, or predicting how information scrambles in a quantum system. These aren't trivial problems. They're the kind that matter for drug discovery, battery design, materials science. The world's fastest supercomputer? The frontier? It's incredible. It can process over a quintillion calculations per second. That's a number so big it's almost meaningless. But there are still things it can't do efficiently. So scientists asked, what if there was a different kind of computer? One that plays by quantum rules instead of classical ones? In October 2025, Google's quantum AI team did something nobody had successfully done before. They created an algorithm, a set of instructions, called quantum echoes. And they ran it on their latest quantum processor, codenamed Willow. Here's where it gets wild. When they tested this algorithm on a specific physics problem, Willow completed the calculation 13,000 times faster than Frontier could. The supercomputer would need 3.2 years to solve it. Willow solved it in hours. But, and this is crucial, that's not the most important part. For years, skeptics have argued that quantum computers are solving meaningless problems. Tasks that sound impressive on paper but don't actually prove anything useful. Like a magician's trick. Impressive looking, but ultimately pointless. So Google faced a question. How do we prove this actually works? How do we verify it's real? This is where quantum echoes becomes genuinely groundbreaking. For the first time ever, Google proved their quantum advantage by doing something seemingly simple. They repeated it. If you run quantum echoes on one quantum computer and get an answer, then run it on another quantum computer of similar capability, you get the same answer. The results are repeatable, verifiable. Not luck. Not an anomaly. Thomas O'Brien, a senior researcher at Google Quantum AI, put it perfectly. If I can't prove to you that the data is correct, how can I do anything with it? This verification changes everything because it means quantum computers can finally be trusted for real-world applications. And here's what makes it even stranger. Google didn't just run an abstract calculation. They used quantum echoes to study actual molecules. They tested how this quantum approach could measure molecular structures using a technique called nuclear magnetic resonance spectroscopy, a real tool chemists use today. What they found? The quantum computer's predictions matched real experimental data. It wasn't guessing. It wasn't approximating. It was accurate. So how does quantum echoes even work? The name is actually a hint. Imagine you send a sound wave into the ocean. It bounces off a submarine and comes back as an echo. Quantum echoes works the same way, but with quantum particles. The algorithm sends a carefully controlled signal into the quantum system. Then it does something classical computers can't easily do. It reverses the signal's evolution, like rewinding time in the quantum world. As it reverses, there's an amplified echo that comes back, amplified through something called constructive interference, where quantum waves add up and become stronger. This echo reveals hidden information about how particles behave inside quantum systems. Information that could unlock secrets about drug molecules, new materials, even magnetic systems. The Willow chip running this algorithm performed over 1 trillion measurements over the course of this project. Think about that. 1 trillion individual quantum measurements. That's roughly a quarter of all quantum measurements ever made on all quantum computers combined. So what does this actually mean for you? For the world? Right now, this breakthrough doesn't immediately solve your daily problems. Quantum computers aren't replacing your laptop or phone anytime soon. Google is honest about that. But this changes the timeline for practical quantum computing applications. We're not talking about decades anymore. Google's chief scientist, Michel Devoret, who won the Nobel Prize in Physics this year for quantum work, says they expect to see real-world applications within 5 years. That means quantum computers could soon help design better drugs faster, create new battery materials that don't exist today, develop polymers and catalysts that revolutionize industries. Companies like JP Chase, Microsoft, IBM, and others are already racing to build quantum computers. Because whoever cracks this first, they don't just get scientific bragging rights. They get access to an entirely new way of solving problems. But here's the real mystery. We don't fully know what else quantum computers might be able to do that we haven't discovered yet. The quantum echoes algorithm is just the beginning. What if quantum computers can solve problems we haven't even thought to ask yet? Problems that could reshape medicine, materials science, artificial intelligence itself? We're standing at the edge of a new computing era. And honestly, nobody knows exactly where it's going next. Here's my question for you. What problem do you think quantum computers should tackle first? What's the big, impossible problem you wish someone would solve? Drop your thoughts in the comments. I read every single one, and the best theories might inspire our next video. If you want to stay ahead of the AI and quantum revolution, if you want to understand the technology that's reshaping everything, hit that subscribe button. We break down the weirdest, most fascinating breakthroughs before anyone else does. Thanks for watching. See you in the next one.